Alright, so we're going to go ahead and start our new unit today, and we're going to be talking about bonding. And mainly Unit 5, we're just going to be talking about the properties of different types of bonds, and then we're going to discuss nomenclature. We're really going to focus on that, and then we'll talk about the structure and things of that nature next unit. Alright, so we need to talk about the differences between ionic, covalent, and metallic bonds. One of the main differences, and I hope that you remember this from one of your previous classes, is that ionic bonds are where there's a transfer of electrons. So this is when you have an electron configuration and one atom needs to gain electrons to become stable, and then the other one needs to lose electrons to become stable. So there's a transfer of electrons to make both of the atoms stable. And covalent, they come together and they share the electrons. And then metallic is a little bit different. You probably haven't studied that before, but we're going to talk about that too. Alright, so let's talk about some vocabulary first. So a chemical bond is the attractive force between atoms or ions that binds them together as a unit. So it is the force that holds two or more atoms together, whether they share the electrons or whether they transfer the electrons to each other. Chemical bonds will form in order to decrease their potential energy, and that will increase their stability. Alright, so I want you to remember that when you're looking at the electron configurations, they are trying to become more stable. And if they become more stable, they will lower their energy state. So they're going to decrease their potential energy anytime that they gain, lose, or share electrons. Alright, so here's some more vocabulary. In your note packet, just make sure you're marking this correctly. Okay, so when we're talking about chemical formulas, if it's an ionic compound, it is called a formula unit. So you need to make sure that by ionic you write down formula unit, because we do call ionic compounds formula units. Covalent compounds we call molecular formulas. We call these molecules. If we're talking about an ionic compound, we do not call those molecules. We call them formula units. Alright, here's some more terms. If we're just talking about a compound, which is two or more elements combined chemically, if it's just two elements, if it's just two elements by itself, it is a binary compound. Bi meaning two. So NaCl just has two elements in it. And it's not talking about atoms, it's talking about elements. So if I have H2O, even though it's three atoms, it's still going to be two elements, so it's binary. If it's more than two elements, it's ternary. So sodium nitrate has sodium, nitrogen, and oxygen. It has more than two elements in it. Alright, so an ion. We know that an ion is an atom that has gained or lost electrons, so it has a charge. It can either be a monoatomic ion, which is just one atom that has a charge, or it can be a polyatomic ion, and that is when you have two or more atoms that have a charge. So NO3, all these right here, when they're chemically combined, they have a -1 charge. So another example of a polyatomic would be SO4 with a 2- charge. So sulfate right here, SO4, this whole molecule has a -2 charge. So polyatomic is when you have more than one atom and it has a charge as a molecule. Talking about ionic compounds, the bond formation happens because electrons are transferred from a metal to a non-metal. Look at this part. from a metal to a nonmetal. This is the big key in whether something is ionic or not. It's the easiest way to tell right off the bat if it's a metal with a nonmetal. So if it's something on the left of the periodic table combined with something on the right of the periodic table, that's an ionic compound. It has a crystal lattice, and I'm going to show you what that is in a minute. Its physical state, it's usually a solid. It has a very, very high melting point. It requires a lot of energy to break the bonds in between the ions. It is soluble in water, or most of them are soluble in water. It will conduct electricity if it has been dissolved in water or if it's liquid. So if I take salt, sodium chloride, and I melt it down, it will conduct electricity. Or if I put salt into water, it will conduct electricity. Alright, so covalent. The electrons are shared between two nonmetals. Okay, the reason that it happens between two nonmetals is because their configurations only allow them to share electrons, not to give them up or take them. So that's when your electrons are shared. We call covalent compounds true molecules because they have different shapes. We have a variety of structures that it can be. It's not just one crystal lattice. They're usually a liquid or a gas. Melting point is low. They're usually not soluble in water, but it doesn't mean that they always, that they're not, that some of them won't dissolve. They're not conductive with electricity, so even if I put it into water, it doesn't matter, it's not going to conduct electricity. And a lot of covalent compounds have an odor to them. Okay, so this is what I mean by crystal lattice right here. So when we have a crystal lattice, that means that you have a very rigid structure. So right here, what will happen is once they form ions, they'll start to form this structure. So maybe this one is the negative ion, and it's going to be surrounded on all sides by positive ions. Okay? And then those positive ions are surrounded by the negative ones. But because you have negative charges and you have some more negative charges, everything's spaced out because these are attracted to each other, but the fact that the positive and the positive will repel and the negative will repel, they're at fixed distances. So it makes a very crystal-like structure. So it's almost like when you make a building. It's very structured and rigid. Okay, so when we're talking about covalent bonds, we say true molecules, and we say that because they can have different shapes. So right here you might see a shape that looks kind of like a triangle or a pyramid. There are a lot of different shapes that covalent compounds can make. They're not limited, or as limited as ionic compounds. Alright, so let's talk about metallic bonds. This is something that you probably haven't learned yet. The electrons are delocalized among the metal atoms. So basically, instead of one or two atoms sharing electrons or one or two atoms stealing electrons from one another, the electrons are shared amongst all the metal atoms that are in that compound. So if I have a piece of aluminum foil, all the atoms are sharing those electrons. And that's because of that d orbital being opened up. We say it's an electron C because the electrons are moving around. They are not in fixed spots. They're able to move amongst all the atoms. They're usually a solid. They have a very high melting point. They're not soluble in water. They do conduct electricity in any form, and that's because of that electron C. All of the properties that metallic bonds have are due to that electron C. They're hard because the electrons are able to move among all the atoms. They are very conductive because the electrons will move amongst all the atoms. Electricity is just a flow of electrons. So when all of the electrons can move and they're not fixed into one spot, you can conduct electricity. We also say that metallic bonds are malleable. They can bend under pressure. They're ductile, which means they can be stretched into wires, and they're lustrous, so they're shiny. All right, and here is our electron C right here. So you'll see all the electrons being moved and shared amongst all of the atoms here. All right, now when we're talking about metallic bonds, really you're talking about an alloy. So those are metallic mixtures that contain at least two elements, and not all of them have to be metal. Sometimes carbon is mixed in there too. But those elements are chosen to give metals more desirable characteristics. So if we're talking about steel, we want it to be very hard, very strong, so we add components in there to make it stronger and harder. Okay, so we're going to talk about bond polarity next time, and I will see you in class.